Okay, so welcome to the um, lesson on solving quadratic equations. So here's the thing about quadratic equations. They're always in the form ax squared plus bx plus c, but to solve a quadratic equation, it's got to be equal to 0. So you can see that this guy is equal to 0, that guy is equal to 0, okay? So the biggest thing you're looking for is when you graph these quadratic equations, this is some sort of parabola that opens up or down, skinny or wide. But what this guy is right here, this is the y-axis. So essentially what you're finding is the x-intercept of the quadratic. And that's what this little essential understanding thing shows you right here, is you can see that if you graphed x squared minus 4, that's this that's this guy right here, right? You graph that, you can see that the equals 0, that's the horizontal axis right here, the x-axis. You can see that it crosses in two spots, and those two spots are here and here, and that's at positive 2 and negative 2. So what we call that is we call that the roots of the equation, or we call it the zeros of the function. And that means that they're literally the x-intercepts. So to do this, there's a couple of things that you can do. So if we look into this one, it says solve by graphing. So you could do this. I'll show you both ways. But what are the solutions of each equation? So x squared minus 1. If I plug this into my graphing calculator, I go y equals, and I plug it in, x squared minus 1, and I hit graph, it looks something along the lines of that. So I can see that if I do that, and then if I go into y2, and I put it in here, and I put this in as 0, I can see that this thing crosses here, and it crosses here. All right, it crosses at 1 and negative 1. So if I were to draw this on my thing here, it goes down here. It looks like, well, it'd be something like this. Okay, so here and here, and that's how you do it by graphing. This guy, x squared equals 0. If I graph that guy, I hit y equals, okay, and I just put x squared in here and put in x squared, and I hit graph, I can see that this guy right here looks like it crosses just right. It crosses just right here, just at the 0, 0 line. Okay, so at 0, 0. So this crosses at 0. If I look at the last one, x squared plus 1, and I say where it crosses the x-axis, plus 1, and I hit graph, I can see that this guy does not come in contact with the x-axis, so that means it has no solutions. All right, so that's what it looks like graphically. Now, if we want to show you real quick, with this one, I can get the x squared alone by adding. So I go right here, and then how do I undo something that is squared? I take the square root. So when I take the square root, I got to take the plus and the minus. So x equals plus and minus 1. That's where we got the two zeros from. This guy right here is already x squared equals 0. If I take the square root of that, right? If I take the square root of that, x is 0. Over here, if I subtract 1 and I get x squared equals negative 1, I have to say no solution because I cannot graph, or I cannot take the square root of a negative number. Okay, and that's what leads into this guy right here, using the square roots. So this one, you got 3x squared minus 75 equals 0. Oh, I'm sorry. You could go back for problem number 1, pause the video, look at the guide. If you have a question, write it down and tell me. Coming back to problem number 2 here, this guy, since there is no b term, I'm going to add 75 to both sides. Okay, and then I'm going to divide both sides by 3. So x squared equals, and then what do I see here? If I go 75 divided by 3, well, 75 divided by 3, if I do that, I get 25. So x squared is 25, and then I take the square root of both sides. So if I take the square root of both sides, I get x is plus and minus 5. Those are my two spots, okay? So a quadratic could give you two answers, okay? A quadratic could give you two answers. Sometimes it gives you one, all right? So check out the Got It, see if you can do that one. Let's take a look at this one right here, problem number 3, choosing a reasonable solution. An aquarium is designing a new exhibit to showcase tropical fish. The exhibit will include a tank that is a rectangular prism with a large L that is twice the width W. The volume of the tank is 420 cubic feet. What is the width of the tank to the nearest tenth of a foot? Don't worry about this guy right here. That's just telling us that we're talking about volume. So when we talk about volume, we're talking about length, width, and height. Okay. So if we take volume, volume is L, W, and 3. So volume they gave us is 420. So 420 equals 3LW. But when you look at it, it says though the length is twice the width. So L is 2W. So if I plug that in, I got 420 equals 3 times 2W times W. So now what I have is 420 equals 6W squared. Now I divide both sides by 6. So W squared is, and then I go ahead and take 420 and I divide it by 6. I get 70. So W equals 70. Now here I'm going to take the square root. I'm going to take the square root of both sides, but I don't need the plus and the minus because I'm only talking about a positive number because we're talking about the width. So the width, and I don't need to break down this radical either. So I'm going to literally plug in my calculator and take the square root of my answer, which was 70, so I get 8.36. So this is 8.36 feet. So the length is double that, okay? The length is double that. All right, so that is it. If you could, go ahead and look under and check the vocabulary words that you understand. Do you know what the standard form of quadratic is? Do you know what the root of an equation is? And do you know what the zero of an equation is? And rate yourself how well you got it. Very simple. Any questions, write it down and let me know, and may the force be with you.